Scholenberg International Private Limited are leaders in HVAC trainings and content development worldwide. Practical course, Certified HVAC Professional, Central Air Conditioning Plants. Overview. About the author. The author, Arvind Dhawan, is a mechanical engineer with specialization in air conditioning with over 45 years experience in air conditioning and utility domain. He is a subject matter expert and certified lead trainer, Level 6 with Electronics Sector Skills Council of India, ESSCI, under the Ministry of Skill Development and Entrepreneurship Government of India, and a visiting faculty with ISHRI. He has contributed to the following. 1. Handbook for Technicians, Air Conditioning and Refrigeration by ISHRI. 2. Multi-Skill Technician Handbook by CARE, Voltas. 3. Trainers PPT, FTAC for ESSCI. 4. App Contents FTAC for ESSCI. 5. Revamping and refurbishments of the course materials for ISHRI. Now, he is developing animated multimedia contents on the entire air conditioning canvas and home appliances. These are available online from Scholenberg International Private Limited. sbgblv.com. Index. Serial. Topics. 1. Air Conditioning Basics. A. What is an air conditioner and air conditioning? B. Temperature, types, thermometers, and temperature conversions. C. Pressure, atmospheric pressure, vacuum, and units of pressure. D. Humidity. E. Air motion. F. Air purity. G. Sensible heat. H. Latent heat. I. Vapor compression refrigeration cycle. J. Energy efficiency. K. Star ratings. L. Energy efficiency of chillers. M. Refrigerants. N. Effect of refrigerants on the environment. Index. Serial. Topics. 2. Psychrometry. 3. Heat load estimation. 4. Types of air conditioning plants. 5. Scaling in condenser tubes, removal and prevention. 6. Servicing of air-cooled condensers. 7. Condenser water piping design. 8. Chilled water piping design. 9. Water pipe fittings and accessories. 10. Water piping drawings and symbols. 11. Water pipe insulation and application of insulation. 12. Installation of water pipes on floor and ceiling suspended. Index. Serial. Topics. 13. Installation of chiller packages, pumps, cooling towers, and air handling units. 14. Duct design. 15. Air filtration and MERV standards. 16. Ducting drawings and symbols. 17. Duct insulation and acoustics. 18. Handmade duct fabrication. 19. Duct installation. 20. Duct and airflow accessories. 21. Servicing of an air handling unit, AHU. Index. Serial. Topics. 22. Basics of electricity. A. Ampere. B. Voltage. C. Resistance. D. kilowatt hour. E. Single phase supply. F. Three-phase supply. G. Neutral. H. Earthing and testing of earth pit. I. Measurement of current and voltage. J. Wires, cables and termination of cables. 23. Electrical switches and controls. 24. Electrical symbols. Index. Serial. Topics. 25. Electrical SLD, single line diagram, of a central AC plant. 26. Electrical layout in a central AC plant room. 27. Mode of measurement of ducts and water pipes. 28. BOQ, Bill of Quantities, of an air conditioning tender. 29. 11 kV power supply tariff and billing in Delhi, India. 30. Management of electric shock. 31. Fire extinguishers. 32. Fire safety symbols. 33. Management of burns. 34. Common troubleshooting in central AC plants. 35. Selection of equipments from manufacturer's data. What is an air conditioner? An air conditioner is like a goods transporter, but instead of goods, it shifts heat from inside a closed room to the outside of this room, where no one has any objection. To explain this, take the case of a simple split air conditioner. The heat from inside a room is absorbed by the IDU, and discarded outside this room, by the ODU. Air conditioning is a process in which the following parameters are controlled simultaneously. 1. Temperature. 2. Humidity. 3. Air motion. 4. Air purity. Objectives of air conditioning. 1. It is used to provide a comfortable working environment for human beings. 2. It is used to provide a special environment for special manufacturing processes. 3. It is used to provide a special environment for medical requirements. Unit of air conditioning. The unit of air conditioning is ton of refrigeration. It is denoted as TR. It is the heat required to melt 1 short ton, that is 2,000 pounds of ice, in 24 hours. It is equal to 12,000 BTU per hour. Atmospheric pressure. What is atmospheric pressure? It is the pressure of the atmospheric air of Earth, also known as barometric pressure. This is equivalent to 760 mm Hg, Hg equals mercury. 29.9212 inches Hg. 14.696 psi. This animation shows the air traveling along with the refrigerant throughout the system. This is shown as a black dot. The components of air are: 1. Nitrogen 78%. 2. Oxygen 21%. 3. Other gases 1%. So, if this air is not properly evacuated, it will result in high head pressure and consequently poor cooling. This is a psychrometric chart in IP units. Assume room inside condition: DBT 75 degree Fahrenheit, WBT 62.5 degree Fahrenheit, RH 50%. The enthalpy of the air is plotted as 28.2 BTU per pound. Vapor compression refrigeration cycle, of a DX-type air-cooled chiller. A scroll compressor is generally used in a small-capacity DX-type chiller. The compressor on starting discharges the refrigerant as high-pressure and high-temperature gas. This hot gaseous refrigerant is cooled by the ambient air in an air-cooled condenser. The refrigerant leaves the condenser as a warm high-pressure liquid. The expansion device is generally a thermostatic expansion valve with an external equalizer. It is denoted as TEV. The low-pressure, low-temperature liquid refrigerant leaving the TEV enters a shell and tube evaporator. The refrigerant cools the water in the evaporator, which is then circulated in the AHU cooling coils. Finally, after cooling the water, the refrigerant changes its state to low-pressure, low-temperature vapor. This then enters the compressor through the suction port and the cycle repeats itself. Step 8. Enter derived design data at the top of the heat load estimation sheet. Air conditioning heat load estimation, calculations continued. Air conditioning heat load estimation, calculations continued. The images of the major parts of an air-cooled air conditioning plant are: 1. Air-cooled chiller package. The images of the major parts of a water-cooled air conditioning plant are: 1. Water-cooled chiller package. Scroll compressor. In a scroll compressor, there are two scrolls. One is a rotating scroll. This is fitted to the shaft of the motor. The other scroll is stationary. It is larger than the rotating scroll. It is placed above the rotating scroll. The refrigerant is squeezed continuously by the action of the rotating scroll. Therefore, the flow of the refrigerant is smooth and not intermittent as in the case of a reciprocating compressor. In this compressor, there is no suction valve. The discharge valve is outside the cylinder. Therefore, the displacement of the refrigerant is 100%. The refrigerant enters from the outer side between the two scrolls. As the inner scroll rotates, it squeezes the refrigerant out from the top center. Below is the animation of a screw compressor. 2. Chilled water pump and condenser water pump. 3. Chilled water and condenser water piping, accessories, and controls. 4. Air handling unit. 5. Cooling tower. The animation below shows the cleaning of the fins of the air-cooled condenser, with a steel wire brush. Descaling method using descaling chemical and brushing. 1. Switch off the main switch and fix LOTO. 2. Arrange the setup as shown below. 3. Open service valve SV1 and SV2. 4. Close butterfly valves BF1 and BF2. 5. Circulate the descaling chemical solution through the condenser. After some time, foaming will start in the solution. Again, clean the tubes with the brush. The animation below is of a typical condenser water piping. The animation below is of a typical chilled water piping. Friction loss in open loop system, Schedule 40 pipe. Pump discharge pipe sizing. Assume a 100 TR system. Flow rate equals 100 multiplied by 4 equals 400 US GPM. Select velocity 10 FPS. Steps. Take the friction loss chart for open loop system. Plot GPM line 400 US GPM. Plot velocity line 10 FPS. Mark the point of intersection. Select the pipe size passing through this point. The pump discharge pipe size is 4 inch. Friction loss in closed loop system Schedule 40 pipe. Pump discharge pipe sizing. Assume a 100 TR system. Flow rate equals 100 multiplied by 2.4 equals 240 US GPM. Select velocity 10 FPS. Steps. Take the friction loss chart for closed loop system. Plot GPM line 240 US GPM. Plot velocity line 10 FPS. Mark the point of intersection. Select the pipe size passing through this point. The pump discharge pipe size is 3 inch. Water pipe drawing symbols. Below are the typical piping symbols used in a piping drawing. Typical piping layout in an AC plant room. This is the animation of application of chilled water pipe insulation. Step 1. Clean the MS pipe and apply Japan black paint over it. Step 2. Apply Japan black paint on the joints of the insulation and then place it on the pipe. Step 3. Finally fix self-adhesive aluminium tape over the joints. Steps for installation of condenser water or chilled water pipes. Sealing suspended. 1. Drill 2 holes in the concrete ceiling, for suspension rods. The distance apart should be sufficient to support the pipes along with the wooden blocks, comfortably. Two. Insert dash fasteners into these holes. 3. Insert fully threaded suspension rods into the dash fasteners. 4. Take an MS angle of suitable size, with holes for suspension. Suspend the angle from the suspension rods. 5. Place the wooden blocks on the suspended angle. 6. Place the pipes on the wooden block. Take lifting steel ropes. Pass them through the lifting holes provided on the chiller. With the help of 2 lifting cranes, lower the chiller on the RCC foundation. Rigging. Ensure that the final resting place of the chiller is smooth. Take a 0.63 mm GI sheet and cut it to the size of vibration isolation pads. Use the vibration isolation pads provided by the chiller manufacturer. Now follow the following steps. 1. Place the GI cut piece over the floor at the position of the chiller. 2. Place vibration isolation pads over the GI sheet. 3. Lift the chiller by hand rigging and place it on 2 hand pellet trucks. 4. Move the chiller to the exact location and place it on the vibration isolation pads. 5. Check the unit level by placing a level on top of the evaporator. Ensure proper leveling by adding additional GI sheets as mentioned above. This is the animation showing the pre-filters and refilters. Typical installation of filters in an air conditioning system. Typical ducting drawing. Typical ducting symbols. This is the animation of installation of self-adhesive nitrile foam insulation on duct. This is the animation of installation of self-adhesive acoustic liner in duct. Steps for hand fabrication of GI ducts. 1. Measurement. 2. Marking. Steps for installation of hand fabricated GI ducts. Drill 2 holes in the concrete ceiling, for suspension rods. The distance apart should be slightly more than the width of the duct plus insulation, if it is an insulated duct. Insert dash fasteners into these holes. Insert fully threaded suspension rods into the dash fasteners. Suspend one end of the supporting angle, from one of these suspension rods. Now lift the duct, and fix the other end of the supporting angle to the second suspension rod. Finally, adjust the level of the duct from the nuts on the suspension rods. Typical layout of a duct installation. Join the various sections of the duct with nuts and bolts, to complete the installation. Duct design. Duct airflow accessories. The air-conditioned air after transportation has to be delivered inside the space to be air-conditioned. This is done in 2 ways. 1. Delivery from the wall. 2. Delivery from the ceiling. The wall outlet is called a grill. The ceiling outlet is called a diffuser. Types of grills. The following are the images of types of grills. Linear bar single deflection grill. Opposed blade volume control collar dampers for grills. Types of diffusers. The following are the images of types of diffusers. Square diffuser. Opposed blade volume control collar dampers for square diffuser. What is voltage? Voltage is the pressure that pushes the electrons to flow in a conductor. The unit is volt and is denoted by capital V. What is resistance? Resistance is the pressure that opposes the flow of electrons in a conductor. The unit of resistance is ohm, denoted by the symbol. This is a three-phase power supply layout in an air conditioning plant room, showing earthing. Construction of the main electrical panel. This is the general arrangement of a main electrical panel of a central AC plant. This electrical panel has the following features. 1. All cables enter the panel from the bottom. 2. Cable alleys are provided for all the cables. 3. The main power supply cable is connected to the main switch at the top. 4. A main bus bar arrangement is provided in a separate chamber at the top. This is energized by the main switch. 5. All the switches are connected to the main bus bars, by a bus bar arrangement or wires in bus bar alley. 6. Finally, outgoing cables from the switches connect the respective equipments. 7. Main power indicators and metering device are placed in a separate chamber below the bus bar chamber. This drawing shows the general arrangement of the following. 1. Outer enclosure. 2. Main bus bar. 3. Main power indicators and multifunction meter. 4. Main incoming switch. 5. Main incoming cable. 6. Interconnecting bus bars. 7. Individual switches with indicators for individual equipments. 8. Outgoing cables to various equipments. 9. Floor stand. SLD of a typical air conditioning plant, the load in kilowatts of each feeder is mentioned. Typical legend shown in an electrical SLD of an air conditioning plant. Below is the image of a duct sizer. Step 5. Calculate the size of main duct 1. Go to band 4. Check which two dimensions match. One on the green scale and the other at the bottom. These are A. 20 inch by 19 inch. B. 45 inch by 8 inch. Step 13. Mark all the duct sizes on the drawing. Practical course, Certified HVAC Professional Central Air Conditioning Plants. End of the tutorial. Thank you for being a part of this learning process.